Now let's compare non-directional and directional tests. And we're going to work just on one side of HO. Of course, if it was directional, that would be the case anyways, right? We would be here no matter what, or here, but we'd just be looking at one tail. If it's two-tailed, then I perhaps should have drawn, what's going on here, but it's identical, it's mirrored from this side, right? So whatever happens on this side happens on this side for a two-tailed test. All right, so the first thing, let's pretend we want to establish the critical value for alpha 0.05 in one tail. Well, if we're using 0.05 in one tail, instead of splitting the 5% up and say 2.5 goes to the left and 2.5 goes to the right, we're going to put all 5% in one tail. So we have to imagine what that would look like. And let's just guesstimate that this is 5% of the distribution. All right, well, if that's the case, because we're putting it all in one tail, this would be your critical value, right? Whatever this number is right here, that's the critical value using an alpha 0.05 and a one-tailed test. All right, 5% here. Now, what about if we wanted to still use alpha 0.05, but this time two-tailed test? Well, that means you're going to have to split up your 5%, and half goes to one tail, half goes to the other. So if that's the case, and we split 5% in half, that means in this tail we have to have 2.5%. Well, 2.5% is less than 5%. So we have to establish what the critical value would be to give us 2.5% in the tail. And this critical value is going to have to be a larger number, right? Your test statistic, remember, gets bigger and bigger and bigger as we move towards the tail. Probability is going down. So whereas this critical value could have been maybe a 3, maybe this critical value is going to be a 3.5. I don't know what number it is, but it's going to be larger. And that's because we need to shrink the area. All right, so let's just hypothetically then say that this is the critical value for an alpha 0.05 two tails. Now let's look at a critical value for alpha 0.01 one tail. Well, if it's one tail, that means we're going to have all 1% in that one tail, right? We're not splitting it up. So now let's imagine that this area here represents 1% of the area under the curve. So now whatever this number is here, that becomes the critical value for alpha 0.01 in a one-tail test. And then finally, what if we wanted to use alpha 0.01 but two tails? Well, if you use alpha 0.01 two tails, you've got to take this 1% and divide it in half. So what you're going to have here is a 0.5%. The other 0.5% is going to be over here in this tail. So here we have a 0.5%. Once we have these four, and we just use logic, right, to establish the critical values, once we have these four, we can figure out, well, which one would make it easiest for us to reject HO? And the easiest is if we put all 5% in one tail and do a one-tailed test. All right. What is the next easiest? The next easiest, as far as to reject HO, would be alpha 0.05 using a two-tailed test. The next one would be alpha 0.01 one-tailed test. And what would be hardest, most difficult to meet the criteria for rejecting HO would be alpha 0.01 two-tailed test. That area under the curve is the smallest area, the smallest target we're trying to hit. Plus this critical value is the largest number. All right? Now, it will always, as long as you compare apples to apples, it's going to be easier to reject HO using a directional test. So I said compare apples to apples. So if we were to compare alpha 0.05, one tail, and alpha 0.05 two tail, that's comparing apples to apples. Which one is going to be easier, the two tail or the one tail test? It's the one tail test, right? It's easier to reject HO with the one tail test. All right, what about alpha 0.01 to alpha 0.01, so apples to apples? What's easier, the two tail or the one tail? The one tail test. It has a smaller critical value and a larger target area. So regardless, if you use alpha 0.05, it's easier to reject HO using the one tail test. If you use alpha 0.01, it's easier to reject HO using the one tail test. You're doubling your rejection zone, right? So it's always going to be easier using a one tail test. Now you might think, okay, one tail test makes it easier. Maybe we should always be using a one tail test. Why not, right? Why not make it easier? Well, a couple of things before I explain. Just reviewing what we learned here, right? We know it's easier to reject HO if you use one tail. And we know that that's true if we use alpha 0.05 versus alpha 0.01. It's still the case if you compare one versus two tail for 0.05, it's easier to reject if it's a one tail test. Similarly, if you use alpha 0.01, if you compare one versus two tail, it's easier to reject HO using that one tail test. Now, here's why I'm going to say don't automatically use a one tail test. Some people snub their noses up at one tail tests. They think you're making it too easy for yourself to reject HO if you use a one tail test. Now, it's kind of ironic because these people are thinking it's always going to be harder to reject HO with a two tail test. But in reality, what if you compared this one to this one? This is actually more conservative, right? Even though this is a two tail test, alpha 0.05, if you were to adopt a one-tail test with alpha 0.01, this one would be more conservative. It would be harder to reject HO here. But researchers sometimes don't think all the way through, like they don't think things all the way through. They just assume, oh, you did a one-tail test, you made it too easy on yourself. Okay, so it's like, well, but that would have been making it easier on myself. Doesn't matter. All right. So what I recommend is start with two-tail tests. Start with this one. It's the most conservative, least likely to get significant effects, but you're keeping your risk of a type 1 error very low, and by using that two-tail test, you're impressing other researchers. If you can't get a significant effect here with this criteria, then use this criteria. All right, we tend to stay away from this one. Use this one. And if you still can't get a significant result using this criteria, then go ahead, do that one-tail test for alpha 0.05. It's better that you use this and get significant results than to bend into kind of peer pressure and you worry about others snubbing their noses up at you.